About sequences is what we talked about. Arithmetic and geometric sequences. Alright. So let's use the books here. What is the pattern?
4.
Plus 4. So that makes this an arithmetic sequence when you add plus 4 over and over. Add the same value over and over. You could be adding a negative over and over, so it could be going down. So adding and subtracting the same thing. Yeah, so we wrote this two ways. I don't think, so the first way that we wrote it is we like backed up one step and then we started adding on. So if I backed up one step, what would go before this? -2. And then you just keep adding 4 over and over n times. N is the number of the term. So the first time we're going to add 4 to get to 2. The second time we're going to add 2 4s to get to 6. 3 4s to get to 10. So that's what it looks like. This, called this, I feel like when we did this, I didn't really use this word. I feel like they didn't use the word either, but that's the explicit definition. And then the one we just graded, called the recursive definition. And on that one, you have to start by defining the first term. First term is 2. And the next term is based on the previous term. That's how we write the previous term, which Leo got completely. And then you just say plus 4. This is the recursive definition.
On the explicit version, what's the -2?
It's kind of the ghost that would come up front here. So it's kind of like our starting place. So when we plug a 1 in for 4, it gets us to the first. So we got it by, because the pattern is plus 4, what would come before this?
Okay.
So you -4 to go backwards. All right. That was the last. Oh, well, and then there's geometric also. Actually, I do need to talk about that a little bit. Okay. Guys, what's the pattern on this one? Divide by 2 or times a half. Basically, the denominators are being multiplied by 2. So this is called a geometric, when you multiply by the same value over and over. Dividing by 2 is like multiplying by half, so they're both, either way, it's multiplying and dividing are kind of the same thing. Geometric sequence, and that thing that we're multiplying, in this case, the 1/2, we're going to need this today. It's called the common ratio. It's just the number that gets multiplied over and over again in a geometric sequence. Okay, the common ratio is 1/2. I don't know if I want to take the time to define. Maybe I will. Alright, so the explicit definition, if we back up, if we divide, so we're multiplying by 1/2. If we divide by 1/2, what would come right before this is 1. So it's 1 times 1/2 today. Now, when you want to multiply the same value over and over, you use an exponent. That's what an exponent does. It makes you multiply 1/2 n times 1/2 times 1/2. When you want to add the same value over and over, that's when you use it times n. Because if n was 3, that would be like adding 4 3 times. That's what multiplying does. So anyway, on explicit arithmetic, it looks like this. On geometric, it looks like this. When you want to multiply the same value, or if you put divide by 2, we don't really need parentheses there, All right, and then the recursive is define the first term, it's 1/2. And then how do we get the new term? We use the previous term times 1/2. I guess we put the 1/2 in front usually. All right, so explicit, recursive. All right, today, those are called sequences. Today we're talking about series, which are very closely related. So a series, you get the terms by adding. So instead of like 2, 6, 10, 14, it's like 2 plus 6 plus 10 plus 14. Okay, anyways, and what we're going to be doing is finding the sum of these series. So this pattern, this would still be called an arithmetic series. Okay, you guys see the difference? The other one was like this. Okay. So what we'll be doing is like finding the sum of these. So this could go on forever, or it could just stop right there. So if I write S of 4, that means what's the sum of the first 4 of these? So you can do what's that plus that plus that plus that. Okay, that would give you the sum. But sometimes it gets really, really long. So there's a little formula somebody once upon a time figured out. And it's written in your book on 487. So t sub 1 plus t sub n over 2. So let's just do a basic one here. Let's do like 2, 4, 6, 8, 10. Oops, forgot the pluses. Dot, dot, dot. Okay, so I'm just adding the evens together. So what if I wanted to say what's the first 20 positive evens added together? So we'd be asking what's S of 20? What's the sum of the first 20 in this series added together? So what does the N stand for?
S.
The number of terms we're adding together. And how many are we adding together? 20. That's, these two are the same right here. So we would put a 20 right there. Okay, and then what's T sub 1 stand for? The first term. In this case, that's a 2. What's T sub n stand for?
Whatever number that you want.
The nth term. In this case, we want to go all the way out to 20. So in this case, it would be the T sub 20. It would be the 20th term. So what would the 20th term be without me writing all those out there? Well, the first term is, yeah, the first term is 2, the second term is 4. What's the pattern? It's just, the fifth term is 10. It's just the number of the term times 2 gives you the term. So the third term is 6, the fourth term is 8. So the 20th term will be 20 times 2, will be 40. Okay, and then there's always a 2 on the bottom, and then work that out, that'd be 42 times 20 divided by 2 is 10, so it'd be like 420. Okay, so that's how you can find it real quick. don't know if I want to explain why that works. Probably not. I remember somebody in college explaining it. I don't remember which of my teachers it was, but I remember it. Yeah. Maybe somebody in college will tell you. You guys don't care, probably, anyway. Okay, on the next page, it says the sum of a geometric sequence. Pretty similar looking. Well, it is different. But we'll be using that when we get to the geometric part. So it's the first term. We do need to talk about a little bit. Over 1 minus r. Okay, what does the r stand for here? Okay, the r stands for the common ratio, which means what's the number that's being multiplied over and over again to get the new term. Actually, the book gave a little example. We probably can look at that. Let's see, 54. So, can you guys tell the pattern on this one? What is the pattern here?
Times -3.
Times -3. So instead of writing like 2 plus -6 plus 18 plus -54, yeah, when you multiply by a negative, it keeps alternating between positive and negative, right? So they wrote it like that. Yeah, what's the common ratio on this one? It would be -3, because -3 is the number that they keep multiplying over and over to get the new terms in the sequence. So when you go to plug it in, t sub 1 still stands for the first term, which is a 2. R is the common ratio, it's -3. You'd have to put -3 in parentheses there because that negative is a part of the ratio. And if you don't, when you go to the exponent, it won't apply to the negative. So you do need the parentheses there. And on the bottom, it's 1 minus -3. So you could just say 1 plus 3. But anyway, that would give you the sum of the... oh, I didn't choose an n, did I? Well, okay, if n was like 20 like we did last time, you just plug 20 right there. Whatever. All right, let's jump in and try these. I don't think they're too bad. It's kind of like plug stuff in. There is a little bit of... May take some getting used to. Okay, so can I just drag that now? Nope. Okay, I'll write it again. Okay, this will give us the sum of the first n terms in a series, arithmetic series. All right, just copied it from 487. So on number 1 it says S of 10. So in other words, they want us to find what's the sum of the first 10 terms of the series that they give us. And they just tell us that the first term in the series, t sub 1, is 3. So what am I going to put in for n right here? 10. Okay, what am I going to put in for t sub 1? 3. What am I going to put in for t sub n? T sub n would be t sub 10, which they just tell us on the problem is 39. So they're kind of just telling us what to plug in. And then all that's always divided by 2. So, let's see, it's kind of like 210, yeah. Number 1. Number 3. S of 50. Okay. So, I guess I'm going to leave that there. So what is my n value? What's gonna go up front? 50. Okay, what's my t sub 1 on number 3? You gotta look at the problem. It's 5, it's the first one. Okay, now this time they don't tell us what s sub, or t sub 50 is. Like what's the 50th term going to be? Yeah, what is the pattern there? They're going up by 5. So the first term is 5, second term is 10, third term is 15. So it's like 1 times 5, 2 times 5, 3 times 5. So the 50th term will be 50 times 5. So that will be 250. Yeah, I'm not going to try to do this one in my head. T sub n equals 5 plus 3. Okay, so s of 12 would equal, so how many terms are we using? That goes in front, 12. What is the first term? This one's a little bit different. What's the first term going to be? Okay, the first term is going to be t sub 1, which means, how do we get t sub 1? We plug in, whoops, sorry I wrote that wrong. We plug in 1 for n. So yeah, 5 plus 3 times 1 is 8. Yeah, so they gave us a little explicit definition up here. So the first term is 5 plus 3 times 1. So 8 is the first term. Plus, what is the last term? 12, the 12th term.
So you plug in 12?
So you plug in 12. 5 plus 3 times 12, I believe is 41. It's always over those. 49 times 6 is like 50 times 6. 300 minus 6. 294? Yeah. I still got it. Well, maybe I could explain it on this one. Dot, 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 dot. Okay, so they don't tell us like the number of terms to add up, so that means they want us to add them all together, basically. Maybe I could explain why this, on this one, why this formula works, I guess, it would be a good one. So if you add the first and last terms, you get like 1,001, right? 1,000 plus 1. If you add the second and the second to last together, you get 1,001. If you add the third and the third to last, you get 1,001. So the sum of these and these and these and these and these, and as you go towards the middle, is all 1,001. And how many of those are there?
500.
Yeah, there's half of these. So you take, I don't know if I can turn that into formula. You take the number of terms there are in and divide that by 2. That's where the 500 comes from. Okay. And in the parentheses is like 1 plus 1,000, whatever that is. The first term plus the last term. That happens 500 times. So that's where that part comes in. I don't know if that makes sense. So this would give us like 1,001 on this one. And this would give us 500 times. But they just write it like that. Okay. Anyway, I tried. We're moving on. Alright, so how many terms are we adding together? 1 1,000. What's the first term? 1. What's the last term? 1,000. Okay, divided by 2. That's kind of an easy one. What does that come out to? 500,500. Guess I should have done that. All right. So on, you guys figure it out. How about number 6? It says the first term is 5, the third term is 11, but they want you to go to the 40th term. So what must the pattern be?
Going up by 3.
Yeah, going up by 3, because the third, it's not the second term is 11, it's the third term is 11. So from 5 to 11, that's a gap of 6. So it must have gone up by 3 twice.
Sorry, Robbie, do you have Caitlin Robertson for algebra?
Robertson.
Uh-huh. She's an 8th grader. Is she in here for algebra?
No.
No. Okay, then she don't need to be in there.
I was like, oh, am I forgetting the student's name?
That'd be really awkward if she wasn't your own.
At the end of the year.
Wouldn't put it past me. All right. Yeah, at the beginning of the year, I kind of panic and I'm like, oh, shoot, what's everybody's names? I don't have a great memory. Number 9, find S of 8 for the geometric sequence. Okay, so we're going to geometric sequence, so we need to switch our formula up. So I'll rewrite that. So this one's at the top of page 488. S of n equals T sub 1 times 1 minus r to the n over 1 minus r. I'm not going to make you guys memorize these. I'll just, just have to be able to use them. Okay, so on number 9, they're just telling us what the r is, the common ratio. It's a number that gets multiplied over and over. For 9a, they want us to use 1/2. And we're starting with t sub 1 equals 8. So, also they want us to find s of 8. It says that in the problem. So t sub 1, the first term is 8. That's just a coincidence that those are the same. It's not going to be like that. Okay, 1 minus the common ratio they want us to use on 9a, they just told us, is 1/2. You guys know why I'm putting 1/2 in parentheses here? Okay.
So it's actually like
If you put an 8 right there, it looks like it might just be on the numerator, and that would be wrong. So let's make it clear it's on the entire fraction. It's 1/2 times 1/2 times 1/2, not just 1 to the 8th over 2. Your calculator might be able to do it without that. It kind of depends on what your calculator is. But if you have a nice one, basically, you don't need a parentheses. Okay, why did I put an 8 right there? The nth term, the number of terms we're adding goes right there, so that would be the same as this. Okay, I wish they would have used a different starting term, because that looks like it's supposed to be the same. It's not. 1 minus r, so the r they told us was that half. Alright, so that's it. Whatever that. I'm definitely not doing that one in my head. Okay, for B it's almost the same thing. They just want us to use negative 1/2 for the common ratio. So it will just look slightly different. Oh boy. Okay, so these are powers of 2 is what they're telling us the pattern is. This is like 2 to the 0, this is 2 to the 1, this is 2 to the 2. So the reason they put a -1 here, because the first term needs to be 1 minus 1, needs to be 2 to the 0. So they had to put a -1 here. Okay, so they just, is this an arithmetic or a geometric sequence? Series, sorry. Well, we're multiplying by 2 here, so it's times 2 times 2, so it's geometric. So we need to use that formula that we just used on 9. Alright, so what is the first term? 1. And then we're supposed to do 1 minus the ratio to the nth power. Okay, what's the common ratio on this one? How do we get from 1 to 2 to 4? Times 2. So that's what would go right there. Okay, we don't know how far we're going. We're just going in far, so we're keeping that as an n. And on the bottom, it's 1 minus the common ratio, so that's 1 minus 2. Okay, we can clean this up a little bit. So what's 1 times that stuff? Same. And what's 1 minus 2? And how do I divide this by -1? Just divide both those by -1. So that'll become positive 2n, 2 to the n. And whoops, this will become 1 divided by negative. They just wanted us to like show that was true. Alright, I don't know if you guys will recognize this pattern. Yeah, that's right. It's times square root of 2. Square root of 2 times square root of 2 is 2. 2 times square root of 2 is 2 square root of 2. So the ratio is multiplying by square root of 2. Alright. So they kind of told us the answer, and they should just asked what it was instead of, but we got to show our work to get, credit for it. So, same formula. What is the first term? Oh, yeah. I didn't really think about this. We kind of need to know. So they went to 64. What term is 64?
Will it be the 16th?
No. I don't know what an easy way. There's got to be an easy way to figure it out. Well, I'm not sure this is the easiest way, but it's not the way I thought of it originally. Can't even right now. Okay. So solving, you guys probably don't even remember. How do we solve something like this?
Don't we move it to the log building?
Yeah, change it to a log. You guys remember how logs work?
No.
ACB?
Let's go.
This would give you the answer. The way I thought of it was 64 is like, well, I remember 32 is like 2 to the 5th, so 64 is 2 to the 6th. But is 12. So there's 12. Oh, what the-
Yeah, Chuck.
you lucky
Oh
bastard.
no!
Schedule.
Oh no!
It's spiritual